All right, this is section 5.1, exponential functions. The first thing we're going to have is they're going to ask you to identify if the equation represents growth or decay. Now I'm going to show you how to do this by looking at the graph. Oops, get back. All right, so we go to the graphing area. If you have anything in there, you can hit menu. Under actions, you can select delete all. And then to get back to a standard window, menu, window zoom, zoom standard. So we're just resetting the graphing area. Now we can put our equation in. We have 0.3. And our exponent, use the little caret, is 6x. You hit enter. And you can see what you have here. I'm going to zoom in a little bit just so we can analyze it. All right. So if you look at this going left to right, we're going downhill. So I'm going to use red just so we can see it a little bit better. Make this one just a little bit thicker. So left to right, like you read a sentence, you're going downhill. This is an example of decay. So let's put in the next one. So I'm just going to delete this. And I'm going to reset my window. And you may be able to tell just from the standard window whether it's increasing or decreasing. There we go. So this is 7. And you want E. You don't want an E on the keypad. You want this E to the left of your 1. And the exponent is negative 8x. Hit enter. So it looks similar to the one that we have. There are very subtle differences. You just can't really see. So this one going left to right, we are going downhill. So this one is also decay. Our next one. So 5 to the 0.7x. Now that one does look different. So let's sketch it out. Not really concerned where it's crossing. But left to right, like you read a sentence, this one's going uphill, it's increasing. This one is an example of growth. So if it looks similar to this is decay. If you're increasing, this is growth. So it's just the general shape. Let's look at this last one. That one, again, left to right, we're going downhill. That's not flat down there. It's getting really close to the x-axis, but it doesn't touch it. But as far as the image goes, it does look like it's flat. It's like it's getting really, really close to X, but it's never actually going to touch it. It's doing the same thing here with Y. So again, this one is also decay. The purchasing power decreases if inflation is present in the economy. For example, the purchasing power of our dollars after 2 years, 5% inflation is given by this model. All right, the 5% is already accounted for in here. They get the 0.95, they take 1 minus the 0.05, which is 5% as a decimal. What will be the purchasing power of $40,000 after 20 years of 5% inflation? So 20 is T, that's our time. So the 40,000 is going to be our R. Net 20 could be inside or outside the parentheses. It doesn't matter. All right, so we're just going to go back to the calculate screen and plug all this in. So 14339.44. And I do believe, let me go back. This does go to the nearest whole dollar, so you don't have any change. So it's that 4 is going to keep that 9 and 9. Okay, so $40,000 20 years ago will only buy you 14,000 materials or whatever in present day value. All right, we need to graph this function on a window. Okay, so let's go back to our graphing area. Delete. And we have a window. So I'm going to change the window first. You can graph it, then change the window, or change the window, then graph. It's irrelevant. I don't ever mess with the X scale and Y scale. And we're graphing just e to the X. So that's going to be e to the X, and you have to put the X in. Hit enter. And that's what it looks like. It crosses, you really can't tell. It does cross here at 0, 1. So I'm going to sketch that out. It's crossing right here. That's at 0, 1. Now they want you to find f of 1, f of -3, and f of 6, rounded to 3 decimal places. Now you could go back to your main screen and plug those in to the equation, or the other thing we could do is, how do we get to those values? That's going to be Control T to get to the table. So when X is 1 and we want 3 decimal places, so it's 2.718. Back up. Then we want X is -3. So 0.049. The 7 is going to round the 9 up, so that's going to be 0.050. Our last one is a +6. So I'm going to make this a bigger so we can look at this. We need 3 decimal places and they have 428. We need to know what's after the 8. So if you're highlighted on that box, the number will appear at the bottom. So 428, there's a 7 after the 8. So it's 403.429. And again, anytime you're dealing with the table, once you're done, hit Control T and turn it off. And if you look at this left to right, we're going up. We're increasing, so this represents growth. So we're going to do another one. All right, so right here, this is our X min. That's going to be our X max. This is what it means with that interval. All right, so let's look at this. -0.6. Okay, so that's what the graph looks like. And we're going to look at some of these transformations. The 4 out front is a vertical stretch. The negative is a y-axis reflection. And the 0.6, not the negative, but just the 0.6, is a horizontal compression. And I'm going to show you how to graph this real quick. So let me share. It's right here. All right, so we have an equation. It's 12e to the negative 0.2. So you're going to click on this. Here's the only tool you can use, the exponential tool. You select it and you click anywhere, it doesn't matter. They're just going to put a generic exponential function in. Then you'll have a box down here where you're going to put the transformation. So instead of graphing individual points, you're going to put the transformations. So you have the 12 in front of the E, that is your vertical stretch or compression. Your horizontal stretch or compression is the 0.2, disregard the negative. The negative is a y-axis reflection, so you would check this box. So I'm going to uncheck it. You see how it's flipping it? Okay, then it's done. You don't put individual points. You're going to put those transformations in. So let's go back to our notes. All right, so that's what all that represents. We do need to find a table of values. Escape, so Control T. And we want f of 10 and f of negative 10. So let's find positive 10. And does it tell me? So it's 3 decimal places still. So f of 10, let's pull that up. All right, 0.009, and there's a 9 after it, so that 9 is going to flip up to a 10. So 0.010. Let's find f of negative 10. So we need to go to negative 10 for our x. All right, again, it doesn't have 3 decimal places. I want to make this bigger. So if I make sure that I arrow over to that block and I look down here at 715 and there's a 1 after the 5. So 1613, 715. Go back to the calculator. Let's turn the table off. And I look at it left to right. I'm going downhill. So that represents decay. And that is it for section 5.1.